Okay, so yes, even though I've done part of this, I haven't really done it all. I don't. Hang on a sec, guys. Yep, it's still recording. Okay. I only showed you guys how to do this. So here we go. Standardisation and the 68, 95, 99.7 rule. So we're going to go through this quickly, but I want to add one more rule here. Okay, and those of you who are doing further would know that there is the rule, which is straight in the middle. There's the mean. So 50% on either side. It's just sort of common knowledge, but I like to always mention it. So then if we want to go one standard deviation away from the mean, we get 68% of the data in there. And remember, the whole data has to be 100%. So if I've got 68% one standard deviation from the mean, I have 16% in each side. Then we can go two standard deviations from the mean. And of course, that means I've got 95%, which means 5% is left over, 2.5 on each side. Okay, I'm going through this quickly because I know we've already covered it. And then 3 standard deviations from the mean. Again, you can see the line is on the 3 there, on both of them. Okay, which means 99.7, so you got 0.3 divided by 2, and we get that 0.15% on either side. Okay, now what is this? This is exactly like moving from the standard deviations, okay, and that's all we're doing. Sometimes you can see this as the z-scores as well, so be aware of that. All right, example 2. Okay, it says the score obtained on an IQ test assumed to be normally distributed with a mean. So highlight these: mean 100, standard deviation of 15. Approximately what percentage of the distribution lies within 1, 2, or 3 standard deviations of the mean? Okay, now it's normally distributed. As soon as you see those words normally distributed, you are doing 68%. Okay, and how do we do that one? We're going to get our mean, take away our standard deviation, so we've got 85, and we're going to get our mean, and we're going to add our standard deviation, so we've got 115. There's a 68%. Then they want 2 standard deviations away, okay, which means we're looking at 95% of the scores. I can add another 15 to here, gives me 130. I can take away another 15 here, that's the easiest way to do it, gives me 70. Of course, I can do 100 times, 2 times the 15 and take it away, but it's easier. The third standard deviation, 99.7, take away 15 from here, 55, add 15, 145. Easier way to do it like that. Question so far? Okay, part B says, what percentage of the scores are more than 2 standard deviations? More than 2 standard deviations above the mean or below the mean. In this instance, less than 70 or greater than 130. So that means we're looking at, and it says 2 standard deviations, and remember, I'll just quickly draw it up. All right, 2 standard deviations, we're looking at 95%. That means we want above it, this part, and below it, this part, because that's 70 and 130. We've worked it out there. But altogether, if there's 95 in here, that means we have 5%. 5% of the scores are either more or less than 2 standard deviations. Any questions there? Okay, I'll clear that one. Okay, now we can convert to z-scores. Again, those of you doing further, this is what we're doing here. The way to convert to z-scores, and the name for it is a standardized value, is to get your x value, you take away the mean, and then you divide it by the standard deviation. I just use that for short. Z equals x minus mean divided by the standard deviation. Okay, they can be positive or negative, and they relate exactly to what we've just done. Okay, 1, 2, or 3 standard deviations from the mean. If it's positive, it means it's above the mean. If it's negative, of course, it means it's below the mean. Okay. The normal distribution, mean is 100 in this case, and standard deviation is 15 in the one we just had. The IQ scores, or standard scores, if we want to do it like that, we've got a standard deviation of 1, and you can see that they go by 1s. 1, 2, 3, 4, -1, -2, -3, -4. Okay, there we go. That is standardized scores. Okay, in a nutshell. Any questions?
When we're writing like the mean and the standard deviation, do we have to use those symbols?
We do. I'm only using them here because no, it's no test calculator, no, it's for the test on Monday. But I'm only doing it here because in the exam and in the exercise, they will use these symbols. But I know generally you guys would use the X with the bar across the top for the mean, okay? And you would use the standard, you would use that for the standard deviation. Get used to both of them, because if the book or this exam shows you that symbol, right, that you need to understand what that means. If you don't, then how are you going to know it's the mean?